Hey guys, it's Miss Silva, and for this lesson, we'll be solving logarithms. Our learning target is I can solve logarithmic equations. To be successful, we need to be able to convert exponential equations to their equivalent logarithmic expressions. So we practiced that yesterday where we get the base and then we switch the other two numbers around. So let's look at the steps to actually solve. We're going to first isolate the exponent and the base, which is the base that has that exponent. It's already isolated, so now we're going to convert it to its log form. So we have log of the base, which is 19, and then we're going to do the switch. We're going to switch the 3 with the expression x plus 4. At this point, you're going to put this part in your calculator. Right now that we're on our calculator screen, we're going to go to Control and Log, which is the button to the left of 1, and then we're going to put the base as 19, and then we're going to put the 3 as our argument. That number inside the parentheses is called the argument. Push Enter and we get 0.37. We're going to round to the nearest hundredth, which that 3 keeps it at 7. So that number is going to replace the log. So 0.37 is equal to, we'll bring down that x plus 4, and then we solve for x. We need to isolate the x now, which means we're going to subtract 4 from each side. And 0.37 minus 4 is negative 3.63, and that's going to be our value of x. Let's go ahead and do example number 2. We first want to identify the base and the exponent, so we need to isolate that. We're going to subtract 4. And then we're going to divide by 3. And now that we have our base and our exponent isolated, we're going to change it into its log form. And we're going to start with log, and then we're going to grab the base, which is 1/2, and then we're going to switch the argument and the exponent. So we've got 5 is equal to x. So let's go ahead and put this part in the calculator. Again, we're going to push Control first, and then the button to the left of 1. We're going to put our base of 1/2. And then our argument is 5. Push Enter, and our value of x is negative 2.32. And okay, go ahead and try the first you try, pause the video, and then come back and check your answer. All right, check your answer. Now go ahead and pause the video again and try the second you try. We're going to do this part together, so hold on for the answer. We're going to go log, and remember when the base is 10, we really don't have to write it, so I'm not going to write it. And then we're going to switch the x and the 38. So we've got log base 10 of 38 is equal to x. Put that in the calculator, and you should have a x equals 1.58. Okay, go ahead and push pause and try the last you try in this section. Okay, check your answer with mine and make any adjustments as needed. All right, so for the next part, or part 2, we're going to solve a logarithmic equations. So for this one, we're going to be doing the opposite. Instead of converting to log, we're going to convert the logs to its exponential form. So the steps are the same. We need to isolate the logarithm, convert it into its exponential expression, type it in our calculator to find our answer. So with this one, it's already isolated. So we're going to get the base, and now the base is going to be the bigger number. And then we're going to switch the argument with the exponent. So we've got to the second power is equal to x. So we've got 7 squared is 49 is equal to x. Let's go ahead and look at the second problem. We've got the log of base 2 of x minus 9 is equal to 4. Our log is already isolated, so we start with the base, and we're going to switch these two, this expression with this number. So 2 to the fourth power is equal to x is 16. Remember, it's 2 times 2 times 2 times 2. That's 16 is equal to x minus 9. And then we just solve for x. Add 9, and we get x is equal to 25. Let's go ahead and look at example number 3. This one does not have the log isolated, so we need to isolate it, which means we need to subtract 15. We get 2 log base 2, x is equal to 10. Now there's two ways that you can answer this question. You can make this coefficient the exponent and then solve, or you can divide by 2, which is what we're going to do. And then from here, we can get, now that we have our log isolated, we're going to convert it into its exponential form. So then we're going to get the base, and then we're going to switch the argument with the exponent, which means we're going to have it to the power of 5 is equal to x. And 2 to the power of 5 is 32. So x is equal to 32. Right, so for example number 4, notice how we have two logs with the same base. So let's see if we can combine them or condense them into one of the logs using one of our properties that we learned yesterday. So let's go ahead. Now we can combine these two using the product property, which means that we can multiply those arguments. And remember, we still need to isolate the log. Let's go ahead and move the 2 to the other side of the equal sign. And now we have log base 8 for x is equal to 2. And then from here, now we can write it as an exponent and see if we can solve. So we're going to get the base, which is 8. And then we're going to switch these two. Power of 2 is 64. And then we divide by 4, and x is equal to 16. And x is equal to 16. Okay, so for part 3, we're going to be solving the log equation, but this time we're going to have to condense the log expression, and then we're going to use the one-to-one property to set the arguments equal. So remember how we solved exponential. They had to have the same base, so we can put the exponents equal to each other. We have the same idea here. As long as the logs have the same base, then we can make the arguments, which is whatever's in the parentheses, equal to each other. So for this first example, we have the same log, and so we can make the arguments equal. So 3x plus 5 equals 8x minus 12. And then we solve for x equal to 17 over 5. Okay, let's look at example number 2. Notice how this one has 3 as a coefficient, so we're first going to make it the exponent using the power property. And now we have log base 2 of x to the third equals log base 2 of 27. Okay, so now that we have the logs the same, then we can set the arguments equal to each other. So for this one, it's cubed, so we do the cubed root to solve for x. And the cubed root of 27 is equal to 3. Okay, let's look at the next one. Again, we have more than one log on the right side. So let's see if we can condense it. We first want to move this to its exponent, and 3 to the second power is 9, so we can just say log base 2 of 9 plus log base 2 of 5. Now for these two, because we're adding them and they have the same base, then we can multiply the argument. So we're going to write it as 1 log base 2 of 45. Because remember, we're doing 9 times 5. And now that we have our logs condensed, now we can apply the property, the one-to-one property, and if they both have the same log base, then we can set the arguments equal to each other. So x is equal to 45. Let's look at the final example. We have, again, more than one log on the left side. So let's apply our rule. We have log base 8 because they're being subtracted. That means we divide the arguments. 48 divided by x. Have those the same. Then we have 48 divided by x is equal to 4. And here we can cross multiply. We have 4x is equal to 48. And then we solve for x. And x is equal to 12. All right, so for your assignment, there are 3 parts. On part 1, you only have to do the odd numbers, which is 1, 3, 5, 7, 9, and so on. On number 3, I realize that it's blank, so just for fun, tell me a joke. And then for part 2, we're going to do even only, and those are 2, 4, 6, 8, and so on. And then for part 3, again, you will only do the odd, which is 1, 3, 5, 7, 9, and so on. Be sure to show all your work. I will post the answer key online. Use the key wisely and enjoy.